Welcome to a new test and teardown video. This time I got a Fluxgate Magnetometer FM100RA from a Canadian company called Electronics Ltd in Ottawa, Canada. So I think this unit is from about 1970, 71 is what I found on one of the components inside. This is a 3-axis amplifier and driver for Fluxgate magnetometer sensors. I don't have the sensor, so that means I cannot power this up. Or yeah, well, I can power it up, but I'm not going to get anything useful out of it. So I'm so sad about that. But we can really enjoy the beautiful construction of this old unit. I think what we can get out of the looking at the front here is that it's capable of running off AC or battery. Oh, look at that. That one is not mounted correctly. Of course, we got the mains, and that will, I think this says baseline, so that's probably a zeroing of the 3 axes, and then this one goes from 0 to 999, so there's like 1,000 steps, and this is a multi-turn pot meter. And then when you have adjusted everything for 0, then you can lock the pot meter so you can't jam the calibration. So there is a driver circuit for the driver coil, and if you crank or select the meter for exciter, I think this is the exciter coil, and this way you adjust the correct drive level, and then you can of course read the 3 different axis outputs, and then I don't exactly know what B plus and B minus is, other than it could be battery voltage or something like that. And that is what I just figured, because I can't find the manual. Obviously this instrument is very old, and you're not going to find a lot. I already took off the top, and let's have a little look. This is the back of the unit. I removed this plate so we can see the 4 plug-in boards, and here's of course the sensor, the head, and the output for your remote recorder. I guess that will be 2 batteries, plus and minus voltages, and as you can see, they were really smart not to mention how many volts, how many amps. I mean, isn't that just bad? And here is the model number and everything if we want to look this up. And this one is wired for 220 volts. So good. I like the way that it's designed with 3 different closed compartments. That is very good for noise and all that kind of stuff. We've got a very big transformer. I mean, hundreds of watts. Really? And somebody modified the power entry with this filter, because that was not originally here, right? Because if you see this mains entry cable, it's definitely cut, and then this filter was put in, and then this little modification was done like that, right? They didn't care to change this cable, so that's how it is. That will be the battery input, and see the 2 batteries, they're connected together here, so that's positive and negative supply when you're running off a battery. So that will be the head input, and look at that, all this ferrite. What kind of funny modification is that? I don't know exactly what to say about that. So you see some different wires here going through their own ferrite, and then some more into another ferrite, and I don't know, what is this funny ferrite kind of what the heck is that? That will be the recorder output. I think this module here is a power supply. We also got some other transformers like that. See, here is... So what is the point with this transformer like that? Yeah. But what? We only got 3 wires for the transformer, right? And they also go like that. That is a little bit strange. Does that go to the main on-off switch? Also a black wire up here. Well, I don't know exactly what that is. But I think that will be a regulated power supply. And here is an op-amp. This is the 1506 Burr-Brown op-amp. I believe this is, one of the first op-amps. This one is from 1967. And it's a little bit difficult to find the data sheet of this op-amp. We've got 1% high precision resistors around here. Diodes, probably some Zeners as well, right? And so this circuit drives or controls the 2 transistors here. So that's probably a regulated power supply, or it could also be a power drive stage for the coil. I don't know really. I'm so sorry. I can't tell you everything. And there we have the 3 different pickup coil amplifiers, and that's probably oscillator and signal conditioning, because that is one that is a little bit special. Let's take them out and have a look. So, power booster. So that power booster is also a Burr-Brown, and it's from it's called 1520. And that. So here's a high voltage signal transformer. When you see diodes like this, each way there's probably some input signal overload protection or something like that, right? And again, high precision resistors. A 660 hertz filter. I guess this is a filter, and that's probably the date code, right? 71. So and that filter here, see, we've got only 3 pins for that filter, and here is a capacitor, and there we go, our fantastic op-amp. I don't know yet what is in and out and power supply, but I'm definitely going to figure this out. I think I'm gonna go and power this up and measure what's going on. As you can see here, this is not a lot. So how complicated can this be really? So let's look at the signal conditioning boards for the sensor coils. And we've got 2 of those fantastic op-amps, and I don't know exactly what that is. Got some... I don't know, what can we see if we try and read 15K 60 kCT primary DC 25 milliamps. I don't know, it's maybe just an inductor, right? It's not the same number, right? SC8. Okay, yes, it is the same number, right? And here's something funny. What is the point of that? And look at that. Here we got 4 resistors and 4 diodes. But look at the other side of the PCB. Here we go with the diodes, and so they decided it's probably better. I mean, the order should not be important, so somebody just put it in the wrong way, right? Let's have a look. It's the same with the other modules, and that resistor is probably something you need to adjust. Oh, oops, look at that. So that was initially going to that capacitor, but they found it's better to go somewhere else. A little modification here. I really like those op-amps. They're also screwed to the PCB, so they're not hanging in the solder joints. So they're really, really heavy. Inside this box, we see the multi-turn pot meters, and that is the AC or DC, called battery or AC. So that's also a multi-turn for setting the drive. That will be the meter switch. So that's all there is to it. See, I was able to trace the power supplies, the negative and the positive, and then the 4 modules. This one is special and the other 3 there are the same. But look at that. This yellow wire, it looks like it goes all the way, and that yellow wire looks like it goes all the way. But here is a trick. Under this one, they actually swap. Ooh, tricky, tricky, huh? So here is negative 13 and plus 13. So that is very interesting to find this information. And I traced down then this the negative power supply goes to this pin, and then the positive power supply goes to that pin of the op amp. And then I assume this is the output, and that will be the negative and the positive. And I did, of course, remove some of the op amps because I wanted to play with them. And on the back side of the op amps, I find this information here, positive and negative. So that is the supply, and pin number 4 will be the output. And then there is a 1 and a 2. That's the 2 inputs of the op amp. X, C, and Y. I think that is offset set for 0. So between these you set a pot meter, and that is not used in this product, but I think that is the thing you can do. So while I was playing around with this, of course I was also playing a little bit with the filters. So we got those filters connected to the inputs and outputs and all sorts of stuff. And I thought that was, let me take another one where the text is easier. I thought that was 660 Hertz, but that is not the case at all. And it's only a high pass filter that will be ground, and then this input and output, they are symmetric, by the way. So it's just a very, very simple low pass filter. So I connected it like this, signal generator and a little bit of load. So let's have a look at the scope on this filter. So here's the frequency. This is 10 kilohertz. Let's just step 1 kilohertz so it goes easier, right? So let's go down 6 kilohertz, 5, 4, so 3, 2 kilohertz. So you see, we got absolutely nothing, well, almost nothing, right? So at 2 kilohertz, let's turn off this light. That's a little bit annoying. So if I crank up the frequency, 2, 3, 4, 5, 6, 20 kilohertz, 30 kilohertz, 40, 50, you see? So that is, of course, the output, right? And I can carry on so that it will be 100 kilohertz. Just carry on all the way to megahertz, right? Oh, I didn't zero that one. Okay, so that is what it is. Just a high pass filter with absolutely no funky things in it. So now I'll play a little bit with the op amps. There we got different types of op amps. This one looks like this. And that one, it's the same. 1506. And I'm still not able to find a data sheet of the 1506. So I don't know anything about maximum voltage or this and that. The only thing I know is in this product we had plus minus 13 volts. And yeah, I'm sorry, I can't really use this product for anything at all. I don't have this sensor, and one of the outputs was definitely not doing the right thing as the other two outputs. And yeah, and without the sensor or anything, it's just absolutely trash. And there was a reason why I got this one, because somebody trashed it. And I think actually I know why this unit was defect. Because when I removed the filters, because I wanted to play around with them, look at that. One of the filters looks like this. So it's completely delaminated. So that was burning hot and melted down. So I tried to open it and see if I could see some melted components in this one, but it's just potted with some stone hard stuff. So that's impossible to open, sadly. Yeah, and there is a power booster. So this will be a power output amplifier. It looks a little bit like the op amps. And we got some pins missing. And again, positive and negative supply. The output and the input is that one. And that one is not connected. And there's no voltage gain, but only current gain. So that is what this thing can do. Of course, I'll play with that a little bit as well. This is called the 1520. And those fantastic, beautiful op amps here. I think this little number we see here in the metal. Where the heck is it? Down there, right? It's very difficult to see. That number here is a serial number. Can you see that serial number right there? So that is different on all of them. And on this one, it is a much lower number. So that one is a lot older, as you can see, compared to all the others. I really hope they all work, because they are super beautiful. So here's a little test. This one is running with a 10K resistor between the output and the negative input, and then a 1K resistor in series with the input to my signal generator and the scope, and the other one is just the positive input is just grounded. So I got a time 10 inverted amplifier setup, right? And the power supply is plus minus 13 volts, and look at that, only 1 or 3 milliamps. So it's really low power. And this is 1 kilohertz. We got exactly 10 times amplification. So let's try different frequencies. Note, this is the peak on channel 1, my input, and this is peak on the output. So of course, if this one is 10 times higher than this, then we got 10 times voltage gain, right? So this is 1 kilohertz. Okay, let's just crank up the frequency to 10. Sorry about that. So that was 10, and we still got, no, we got a little bit higher gain here actually, right? And that is 10, so we go to 20, 30, and see here we see some funny stuff starting to happen. And then we go, oi, suddenly, that is 36 kilohertz and 37. Really? So it just loses its ability to be in regulation, right? And here is 40 kilohertz. How about we go back to 36 kilohertz and just lower the signal like that, and then we go up to 36. Yeah, see, it's all about oop, and then it goes again, and that is 45 kilohertz. Aha, so it's all a matter of 1 volt. Ooh, that's also a 1.3 volt, and then it goes, and then it comes again. Wow, it's doing some really funny things here. Ha! Okay, so let's just give it really, really low level and then crank up the frequencies, and then it goes again. That is 50 kilohertz here. No, 53 kilohertz. Okay, so this is more or less how it's working at at low gain. So I changed the feedback resistor to 100k, and the series resistor here is still 1k. So that is 100 times voltage gain, more or less, right? So let's look at that. 1 kilohertz, and I turn down the input so it's very, very low. Now you start to see some noise here on the input, but I say this one is more or less 100 times more than that one, right, at 1 kilohertz. And now I'm only steering it plus minus 5 volt, so it's far from full. Let's see if I am able to. Yes, that is full. So let's go half of full level. So let's just play with the frequency. So that was 1 kilohertz, and that was 10. Still more or less okay. And then 30 kilohertz, 40. So there's definitely some funny stuff happening at 30 and 40 kilohertz, right? So that is 20 kilohertz. And that is of course 100 kilohertz. Ooh. So yeah, this op amp is of course not a fast op amp, but it's definitely working. So now I'm done testing all the op amps. So I thought I'd also test the power booster. And here it is. Again, plus minus 13 volts. This is only a current gain, so there's no voltage gain in it. So just take my signal generator in here and then the scope. And what do you know? This one goes really, really fast. So this is 100 kilohertz at plus minus 5 volts. So that's 10 volts peak, right? So here we go, 100 kilohertz. Let's just crank this up to 1 megahertz. I don't know if you can see this, but there's actually another curve behind this one, and that is the output. So that is 1 megahertz. Oop, see? 2, 3, 4, and then it's over, right? But it's good to 1 megahertz. So that is definitely interesting. And here's the power consumption again. Almost nothing. And yeah, here we go. Oopsie doopsie. And here's the part number 1520. Power booster. Fantastic. I think I figured this out. If you can remember, in this area we found these two tiny little transformers, and then out here we had this huge transformer with only 3 wires. And look at that, 230 common and 115. So this is of course we call this auto transformers. It's because it's a step up or a step down without isolation. So that is what it is, and this is of course a modification. I can also see the holes in the case is a little bit funny made. So this was done later, I guess, or it was something they installed from the factory when this unit was shipped to Europe. Because if you see here, this brand, Hammond and all that kind of stuff, it says also Canada and all that, right? So maybe this is a factory modification when this unit went to Europe, right? And here we go, the two little Hammond transformers for 115. Two of those, they were connected in parallel, of course, on the input. And then the two outputs, they're exactly identical. The two transformers, 50 volts, 75 milliamps each. Okay, so now look at this. First look at the colors. So that one, the sensor pin, this is the sensor winding of this transformer, and it's exactly the same with the other one. They just went to chassis. Okay, so that means the two green one here and the two green one here, they went to the power supply board, and this is the power supply board here. So here we see something really, really funny. Oh, let me turn on some light. So that is the two green wires from one transformer. And two diodes. They go this way, and then there is a resistor, and then it goes to the positive side, and then it goes to Zener and transistors and blah blah blah. Not that interesting, or not that important for the thing I want to say, really. And then the other transformer, two diodes that go that way, right? And then again a resistor, and it goes to the negative side of this capacitor. So it's quite obvious what we got here, right? A positive about 30 volts and another negative 30 volts made by two different transformers. And because this whole circuit is not using exactly as much power on the positive and on the negative transformer, because one transformer is making only positive and the other one is making only negative, that means because of this, you just can't take the two primary sides of the two 115 volts transformers, you can't put them in series and make this unit run of 230 euro power, right? But what if you turned on your brain just a tiny little bit? That could, have saved a lot of these problems, right? So you take those two windings and make it so that one half of this goes to the negative and the other one goes to the positive. That means you're loading the two transformers exactly the same amount. Now you can put them in series on the primary side. All it took was to move two wires here, and then you didn't need to have and install this big ugly boy here. That's just my take on this. That is so embarrassing. It is absolutely true. Think about it, okay? And if you don't agree, please comment. I would love to hear your challenging. Please challenge me on this statement. Could you? All right. See you. Bye-bye.